Welcome to a lesson on line plots. This is Unit 8, Lesson 13. All right, so a line plot is just another way of displaying data. We've already used bar graphs to display data. We've used line graphs. We haven't learned about circle graphs yet, but that would be another way that you could display your information. A line plot looks kind of like this right here. It looks a little bit like a line, but it's really not a line because it doesn't have arrows on either end. A line would have arrows here and would go on forever and ever in either direction. A line plot can start with a 0 or it could start with any number, and it could go by 1s, it could go by 5s, it could go by 2s, however you want to set it up. The title for a line plot goes on the bottom. All right, so this is just the start of a line plot. And let's say we surveyed our class and we were figuring out how many pets people had. So you go around the room and ask people how many pets they have. And let's say the first person says, well, I don't have any pets. So you put an X there. I'm going to change my colors here. Next person says, I have 2 pets. Next person says, I have 4. And you continue going around. And when you get another person who has 2 pets, you put an X above them. And you keep asking people how many pets they have, and you keep displaying their data. All right, so the line plot gives you a really nice visual display, and you can look at this line plot and you can see, boy, more people have 2 pets than anything else. Nobody had 5 pets, and one person didn't have any, and one person had 3, and one person had 4. So just, you can look at it and see the information. Another cool thing about a line plot is it can make it easier for you to find the mean, the median, the mode, and the range. Let's start with the range. Remember, the range is the difference between the highest and the lowest, and right away you can see the highest number here is 4. The lowest is 0. 4 minus 0 is 4, so the range is 4. We'll do the median later. The mean is a little bit tricky. The mean, you're going to have to add 0 plus 1 plus another 1 plus 2 plus 2 plus 2 plus 2 plus 3 plus 4. So you'd have to add those all up. And then once you did, you divide by the number of numbers you have. So I have 6, 7, 8, I have 9 numbers. So I'd have to divide by 9. Whatever my sum was divided by 9. And that would give me the mean. The median, actually let's do the mode next. The mode is the one that you see the most. And what do you see the most of? 2s. That was the easiest one of all. All right, the median, just like when you had the numbers written in order from least to greatest, you could cross out. You can do the same thing here, only now we're going to cross out the low one here, the high one here, the low one, the high one, the low one, the high one. And now you can easily see that 2 is going to be your median number. So kind of a fun way to find mean, median, mode, and range. All right, so if you have your textbook, you can open up to page 383. I'm going to go to page 383. And this is actually the first textbook example. I gave you that other example because it had whole numbers. For whatever reason, the textbook company decided that they're going to show you line plots with fractions, and I think that gets a little confusing. So on page 383, and again, if you don't have your textbook, that's okay. You can just look at mine. But if you do have your textbook, you can follow along and fill in the blanks like I'm doing. It says the soil samples were taken for 10 days for a biology project. The frequency table shows the number of times the various weights for the samples occurred. You can organize data on a line plot to make the data easier to analyze. Okay, this is kind of a strange situation, but for whatever reason they're weighing their soil samples that they took out of the ground. So they started the line plot for us. So you see the first number in the chart is 1/8, and so they put 1 dot by 1/8. And on the previous example, I used X's on the line plot. You can use X's, you can use dots, you can use whatever symbol you wanted. For the pets, we could have done little pictures of dogs. You can get really creative with your line plot. All right, so they did the 1/8. There's 2 1/4, so that's why there's the 2 dots there. And then we've got to pick up where they left off. So the 3/8, you would do 3 dots here. I probably should have used black, but that's okay. There are 2 1/2s, and there are 2 5/8. Right? So that's what our line plot would look like for that data. The blue line underneath it is where they would like for us to put the title. And you can make up your own name. I'm just going to call it soil sample weights. Very sloppy. Okay. All right. Now we can use that line plot to answer some questions. Okay. So based on these samples, which sample weight is least likely to occur? Now, I think you could answer that one of two ways. The one that was the least number was the 1/8, right? So you could say 1/8 is the least likely to occur, but they also put a 3/4 over here, and there weren't any of those. So I think it wouldn't be wrong to say 3/4 is the least likely either. Number 3 is a little bit easier. Based on these examples, which sample weight is most likely to occur? And you'd have to say the 3/8 because there's more of those than anything else. You probably could have gotten that answer looking over here at the chart. All right. What is the total weight of the samples weighing 3/8 pounds? Well, we had 3 of those. So to find that, you'd have to add 3/8 plus 3/8 plus another 3/8. 3 plus 3 plus 3 is 9. And you know that 9/8 can be simplified, right? It's an improper fraction, so we have to simplify it to be polite, right? To be proper. So it would be 1 1/8. And how did I get that 1/8? I did 8 goes into 9 one time, and then there would be 1 left over. So that's why I have a 1 on top. All right. They gave us a really challenging question for number 5. If the total weight of the samples were redistributed evenly among the 10 samples, what would each sample weigh? Explain how you found your answer. What are they really asking us there? We're going to redistribute it so it's even among the 10 samples. Each of those 10 samples weighs the same amount. How would we find that out? Think about that for a moment. All right, I've gone back to the original chart here. They're asking us to even these out. So what that means is we're really going to find the mean. Okay, the mean is the middle, so if we even them all out. So to find the mean, you have to add them all up and divide by the number of numbers. So there's 10 numbers there. There's 10 soil samples, so we're going to add it all up and divide by 10. All right, so I'm going to make my list going up and down of numbers. So I've got 1 1/8, that's 1/8. I've got 2 1/4, so I've got 1/4 plus 1/4, which is 2/4, same as 1/2. I'm going to write that 1/2 in 8s because I know I'm going to have to add this up. So I know that 1/2 is, or 2/4 is the same as 4/8. So just to make it easy on myself later on, I'm going to keep the denominators all the same. All right. Earlier we did 3/8 plus 3/8 plus 3/8, and we said it was 9/8 or 1 1/8. So I'm going to write my 1 1/8 down there. I have 2 1/2, so 1/2 and 1/2, 1 whole. That was easy. And now I've got 2 5/8, so 5/8 plus 5/8 is 10/8. Improper, right? I'm going to divide that 8 into 10. It goes 1 time. And there's 2 left over, so I've got 1 2/8. Hopefully you can read that. Okay, I'm going to add these all up. Let's start with the 8s. I've got 1/8, 4/8, 5/8. I've got 8/8, right? And then 3 8/8 is the same as 1 whole, so I can rename this whole thing as 4. So my total for all those samples weighs 4 pounds. And I'm going to even it out among 10. So you can think about this as 4 divided by 10 like that, or you can think of it as 4 divided by 10 like this. Okay. In any case, it's going to be 4/10 as your answer. Okay. If you wanted to leave it in fraction form, you could say 4/10, or you could say 2/5. So any one of those three would really be a good answer. So if you evened all that soil out, each of the 10 soil samples would weigh 2/5 of a pound, or 4/10 of a pound, or 4/10 of a pound. We'll stop there, and the next video I'll show you another example.